Now in the fundamental theory of algebra, this is what we have to start from. If fx is a polynomial degree n, degree 3, degree 4, this is on math 3 part 2, this will be page, the pages are not numbered, second last page. You've not stapled it correctly, I think so.
Yeah, I didn't staple it.
Yeah. So if fx is a polynomial degree n where n is greater than 0, then equation fx is equal to 0 has at least one solution in a set of complex numbers. At least one solution will be then set of complex numbers.
So yeah, if n is greater than 1.
N is greater than 0 means anything.
Right, yeah. If it's greater than 0, it will have at least one solution, right?
If fx is a polynomial degree n greater than 0, then fx is 0 exactly n real or complex solutions. So whatever the power, no, those many solutions would be there.
Yeah.
So for the cubic equation, it will have three solutions.
Yeah.
So it may be real, complex.
It doesn't matter. But
it can be real also.
Yeah.
In fact, real numbers are a subset of a complex number.
Yeah.
Real number is a subset of a complex number. So when they say complex number, it's like a real number.
Yeah.
Fine. How many solutions does this equation have?
4.
4, because it's power. How many zeros does this have?
3.
3.
Same thing as solution, right?
Means when you substitute that value, it will become 0.
Yeah.
Find all real and complex zeros of this. You may have to use graphic calculator to get the actual rational roots. So use your graphic calculator and get this. So if you graph this on your calculator, so totally how many roots are there?
2 roots that we can see.
Totally 3. So minus 1 is repeating twice because it's a repeated root.
Right.
So basically you're getting x minus 1 square. It's a repeated root. Remember, when it turns like this, it's a repeated root. Huh? Don't forget.
When it
turns,
changes,
when it touches, then there's a repeated root.
Okay.
That's called a repeated root. Correct?
Yeah.
And the other one is x plus 1, sorry. And this will be what? X minus 2. So how many roots have we got?
3 roots.
3. But this is raised to 5.
So that means there's 2 more.
2 more roots. Now those 2 more roots we cannot see on the graph because those 2 are complex roots.
Complex roots, right. Imaginary.
Imaginary roots. Now how do you find them?
Synthetic division.
With what?
With minus 1.
Now see, this is very important. This is an important sum. So with your calculator you will get the real roots.
Yeah.
But your calculator will not give you the complex roots.
Yeah.
Let me repeat. And remember, these are repeated roots.
Okay.
So what I do is, now see, there are 2 ways of doing it. Look at what is happening on the board.
Yeah.
As you correctly said, we'll do synthetic division with minus 1.
But why not 2? Or could you?
2. I can start with 2 also. I can so 1.
Minus 1 is easier, no? That's why.
No, nothing like I'm going from low to high. Like having some system in my work. Correct?
Yeah.
So 1. Minus 1, correct? Minus 5, 9, minus 9, 1, minus 1, minus 14, 14.
0.
This has to come 0.
So no remainder, basically.
It has to come because that's a 0. Now what we have divided by?
Now you can divide it by minus 1 again? Or
yes, right? Minus 1 again.
What if you did 2?
It's fine.
It's fine?
Fine. But you have to divide twice by minus 1.
You have to divide twice by minus 1.
Yes, because it's a repeated root.
Because it is a repeated root.
So now I'll take 1, minus 5, 9. The answer of this, I'll divide by minus 1.
You can do it by 2?
Yes.
You can?
Yeah.
And you get the same answer.
Final answer will be the same.
Okay.
So 1, minus 1, minus 6, 15, minus 14, 14. Now what will you divide by?
2.
2. So you can take this in any order. You can take minus 1, 2. You can take 2, minus 1. So you can divide first by minus 1, then by 2, then again by minus 1.
So it doesn't matter.
It doesn't
matter. You have to divide it by all of the roots. You have to. To find the
because it's raised to 5.
Yeah.
It's raised to 5. When I divide it once, it will become raised to 4.
Then
Well,
raised
raised
to 3.
to 3.
Then raised to 2. And then you'll get
Yeah.
then you can factor
Correct.
that.
You have to factor that. Then you will
Yeah.
get complex. 2. Now 2 will be, so I'll take this. 1 minus 6, 15 minus 14. So this is 1, 2 under 2, minus 4,
minus
7, 14. So this is 0. Correct?
Yeah.
Therefore, what does it become? Tell me. So what's my quadratic?
It'll be x squared
X squared
minus 4x plus 7 equal to 0.
Correct?
Yeah.
So now, so your x will be what?
X would
Minus
be
b
minus b
plus or minus
plus minus
root b square, square root of b square minus 4ac
yeah
upon
2a. So 2.
correct?
Yeah.
So that would be 4 plus or minus root of 16 minus 28
Yeah.
over 2. 4 plus or minus, what is that? Minus 12?
Minus 12, yeah. Upon 2.
So minus 12 will be, root of minus 12 is what? Minus 4 into 3.
Yeah.
So that's what? 2 root 3i.
Root 3i, yeah.
So root
I
of
because
minus 1.
minus 1, huh? But I is equal to...
See, root of minus 1, root of 4, root of 3. Root of minus 1 is I. Root of 4 is 2. This is 3. So therefore 2 root 3i.
And then you just bring the I on the other side.
So 4 plus or minus 2 root 3i divided by 2. You remove 2 common. 2 2s are 4, correct?
Yeah.
So this and this cancels. So what are my roots therefore?
Wait, how did you remove... Oh, you removed 2 common from the 4.
From the numerator. From the 4 and from this.
Oh, you cancel
This and this, no?
Yeah.
Because then only you can't cancel like this, huh?
Yeah.
There's a plus sign, you can't cancel.
Right.
You have to remove a common factor.
So you got rid of the 2, and then that you made that 2 becomes 2 plus 9. Okay, I see.
So what are my roots therefore?
Roots are 2 plus...
Roots are minus 1, minus 1,
oh, yeah,
2, 2 plus, root 3i, 2 minus root 3i. These are my 5 roots.
5 roots.
And you follow why minus 1 is the repeated root?
Yeah. Yeah.
Now you may probably notice that irrational and complex roots come in pairs. Can you see that they have come in pair?
I see that, yeah.
Come in pairs, sorry. So these are known as this is what they are saying.
The 1 and minus 1.
This.
Oh.
That's your conjugate root theorem.
Yeah.
What's your conjugate root theorem?
Conjugate root theorem is...
says that the complex number roots always occur in pairs.
Pairs as in...
If you have
if you
p
have
plus qi,
right.
you will always get p
minus 3i, right. So if you have factors or something, it says one is 2 plus 3i, the other one will be 2 minus 3i.
Has to be. Automatically.
Because of the square root.
That's your conjugate root, your complex conjugate root theorem.
Yeah. I didn't fill it out, but I'll just do it now.
See, complex conjugate theorem, if f is a polynomial function with real coefficient and a plus bi is an imaginary root, then a minus b is also 0. Means they always occur in pairs.
Because of I?
Yeah, that's a rule, I mean, always.
If I is there, then it's minus.
But it can also happen with irrational conjugate theorem. It also says that if a plus root b is a 0, then other 0 has to be there.
Yeah.
A minus b.
Yeah.
So complex and irrational always occur in pairs.
Got it.
Like boyfriend and girlfriend, they're always together.
Got it.
Huh?
Yeah.
So who's girlfriend of a plus bi?
A plus bi is a minus bi.
Yeah. And who's you invite one, the other will automatically come.
Yeah, all the way.
All the way, yeah.
All the way. Boyfriend and girlfriend.
Yeah. So write a polynomial function of least degree.
Yeah.
That has rational coefficients, a leading coefficient of 1, given that these are the zeros.
So we know the 3 roots are 2,
yeah,
minus 2 minus 5i, and minus 2 plus 5i.
Very good. Why?
Because of
conjugate
the
root.
boyfriend.
Boyfriend, girlfriend, probably. Now, How will you get the polynomial function?
So you would do x minus 2.
Yeah. So fx is equal to x minus 2
equal to.
No, then x plus 2 plus 5y.
Yeah.
X plus 2 minus 5y.
Right.
Are you following that? See, what are we doing here? You will always do x minus p, x minus q, x minus r, and always there's a stretch factor.
Yeah.
But here they have given you that this is 1, so we don't have to bother.
Leading coefficient.
So k is 1, they've given you basically. So you don't have to bother for the k.
Otherwise, we have to.
You have to consider that and take
and
one
then
more
you
point.
use synthetic. Then you get to use synthetic.
Now
to see
how?
if it work.
No synthetic way.
Okay.
We are doing reverse now.
Reverse.
You've been given the zeros, and from the zeros we are finding the polynomial.
Yeah.
You do synthetic when you from the polynomial you are finding the zero. I mean factors.
Yeah.
So now how will you get the polynomial? You multiply these two.
You just multiply it out.
How will you multiply?
X minus 2 squared.
Now you think like this. What is, you remember the formula of p plus q into p minus q?
Yeah.
What is p plus q into p minus q?
P squared minus q squared.
Very good. So that's what I'm doing. So this would be x plus 2 squared minus
5i squared. Right.
So this is x minus 2. What does this mean?
X squared plus 4x plus 4. Minus
25 I squared.
Yeah.
So what will this be? X minus 2 x squared
plus
4x
plus 4.
I squared is
plus 25. Because
it's
minus
I minus 1. So this would be x minus 2 and
x squared plus 4x plus 29.
Now listen, now multiply this.
X cubed.
No, now I'll tell you synthetic multiplication.
New thing.
See, what you do is, this is 1, 4, 29. Can you see that?
Yeah.
Can you see 1 and minus 2?
Yeah.
This have to multiply.
Wait, why 1?
1x.
Oh, because of the leading
1x minus 2.
Oh, right.
1, and so I'm multiplying these two basically.
So you bring down the 1.
Minus 58. 4 to the minus 8, correct?
Yeah. Minus 2.
Minus 2.
29.
Here, you leave a blank.
Yeah.
4.
1.
So 1.
So just like normal multiplication.
2. Normal multiplication. 21, correct? Minus 58.
So it's x cubed.
Correct.
Minus 2x squared.
Plus
2x squared, sorry. Plus 21x. Minus 58. Oh wow, that's actually very cool. That's really cool.
You can also do other guys also. Same answer.
This is how I did it, but it's very similar.
From the zeros, you get the factors like this, and then you multiply.
Yeah.
That would be more fun. Yeah, it is the same thing as that, but this is what it is.
I'm not gonna fill it out. I'll do that later.
Next one.
Next one. Yeah.
So these are the zeros. So which are all the zeros therefore?
Minus 4.
All the zeros would be minus 4.
3 minus square root of 2, and 3 plus.
Therefore, what will my fx be?
F of x is equal to minus x plus 4.
Yeah. You following my note? See?
Yeah.
Because when your x plus 4 was 0, x became minus 4. So you're doing the reverse. You're getting it from 1.
Yeah.
Next one.
And then x plus 3 minus square root of 2.
Reverse the signs.
You reverse the signs.
Yeah. Then?
And then x plus.
X
or minus 3. Minus 3 plus. Minus 3 minus square root of. Wait, why is it minus though?
When your x was 3 plus root 2, To make it equal to 0, you'll get all the terms on one side.
Oh, so you get so you bring the minus.
It's the reverse of what you've been doing so far.
Yeah.
You're getting all the terms on the side. You're getting the factors from the roots, from the zeros.
Yeah, I see. So yeah, of course you bring the sign.
Yeah.
Okay.
Now
you multiply it.
Which two?
The last two first.
Why?
Because
you can see a plus b into a minus b.
So the middle term cancels.
Arey!
The a plus b times a minus b.
Correct? A square minus b square. P plus q to p square minus q square.
Yeah.
So x plus 4. What is this?
X squared minus 6x plus 9. And that's 2. Square root of 2, 2.
Plus
7, yeah.
Now multiply them.
Synthetic, so 1 minus 6, 7 times by 1 and 4. 28, 8.
6 4 by 24.
Oh, you don't carry it?
No carrying.
No carrying, okay. 7 here. And then minus 6, 1.
When you're doing it, it will become very faster.
Yeah, I know. I'm quite good at the synthetic division.
Yeah. So what will this be?
This would be x to the 3 minus 2x squared.
Minus 2x squared.
Minus 23x plus 28. Very nice. Interesting. I think I got it. Just the only thing to remember is when you put it in the brackets, you flip the sign.
You flip the signs. You flip the signs because that's what the formula is. You have to do, if p, q, and r are the roots, factors would be x minus p, x minus q, x minus p.
Right. You think about it like that.
Approximate to real solutions of these equations equal to 0.
Approximate.
Now there are two ways of doing it. Suppose it comes, but give your answer to correct to 3 significant. Means you have to use your calculator. Is minus 3, correct?
Yeah.
Others are not proper.
Right.
Yeah, others are not proper.
You don't want to use those.
You don't want to use this. Yeah.
And then the other one's the same thing.
Yeah. So all that, okay, fine. So only one real 0 and other, okay. So what will I do now?
4.
So now I'll do synthetic division with minus.
With minus.
Right.
4.
Minus 4, yes.
12.
Yes.
0.
Yeah.
0.
Yeah.
0. Oh, sorry. Minus 1. Minus 3.
Okay.
Bring the 4 down. Minus 12. 0. 0. Minus
0, no? Sorry.
0.
0. Correct? 0. 0.
Minus 1.
Minus 1. 3.
0.
Correct? So this became,
to the
0 is equal to
4x to the 4.
So x plus 3, correct? 4x4
4x to the 4
minus 1.
Oh yeah, nice. Makes it nice and easy.
Now can you factorize this 4x4 minus 1? Difference of squares. Can you treat this as 2x square minus 1 square?
Minus 1 squared will make it plus 1.
So what will this become?
X plus 3.
2x square.
2x squared.
Minus 1.
Minus 1.
2x squared plus 1.
Oh. This would also work.
Correct. So therefore, x is equal to what?
Minus 3.
Minus 3 or
x
2x square minus 1 is equal to 0.
Yeah.
X square is equal to half. So x is equal to what? Plus or minus 1 over root 2.
Because you square rooted the
square root both the sides.
But how did you get? So would I be expected to do that, to split it up like that?
Sorry, difference of squares, huh?
So if I have 4x to the 4 minus 1, would I be expected to split it up by difference of squares?
Yeah. Because raised to 4 is a square only, no?
Uh-huh.
It's a square of a square, no?
Yeah, actually it makes sense. I don't know why I didn't think of it. I should remember that.
Okay, next one. Or 2x square plus 1 is equal to 0.
Yeah.
Solve, tell me, next
So
step.
minus 1 upon 2 and then square root of 2. So 1 upon plus minus 1 upon square root of 2.
So 2x square is equal to minus 1.
Divided by
X square is equal to minus 1 over 2.
2.
X is equal to plus or minus root. Correct?
Yeah.
So that is equal to plus or minus I upon root 2.
Upon root 2. Because I is equal to square root of negative 1.
So give your answer correctly.
360.
Approximate real solutions. So which are my real solutions?
Minus 3.
Real solutions. Minus 3. This is, what is this? Plus 0.707. 1 over root 2.
Yeah.
And minus 0.707.
No. It was, minus and then plus. And then 0. Yeah, right. Yeah.
Because 1 over root 2.
Yeah.
And those are the two complex.
And if the graph goes like this, like with the sleep, like this, then it has 2.
Repeated.
Repeated.
See, I
need to remember that.
You need to remember. So that finishes